This conference will now be recorded.
Okay. So yeah, I was asked to come along today to talk about NR60 Mk2, and so the sort of overlying title is why NR60 Mk2 S&C, and trying to dissect that a little bit. So it's strengthening the case for NR60 Mk2 S&C layouts, and then as Gilles just mentioned, it's describing this journey from the first pilot site to this business as usual, and we'll explore that a little bit as I go along. So a little bit about myself. As has already been said, I'm a principal engineer for S&C within Network Rail. I normally work within the S&C engineering team. That's part of the technical authority based in Milton Keynes, but I'm currently on a secondment to the supply chain operations team within Network Rail, and this is working with our supply chain on a number of different initiatives, but part of this is involved with the expanded rollout of NR60 Mk2. As we all see on LinkedIn these days, people talk about work anniversaries, and I've actually had 2 work anniversaries this year. So it's actually 25 years since I started working for Balfour Beatty, which was my my entry into S&C. That was obviously working for a manufacturer at Sandy Acre, and it's also 15 years since I joined the national engineering team and started working for Jeff Southern. I'm sure many of you remember Jeff. So yeah, they're my two work anniversaries. So like I said, this one I'm going to talk about the sort of 2 parts here: the journey, and then the challenges. So I'll come on to the journey in a moment. The bit about the future I'm going to leave till the end, but there are a number of challenges, and I think partly why I've been asked to come along today. So my challenge I've split into 3 parts. One is it the right solution? Is NR60 Mk2 the right engineering solution? Then it's a challenge around how we as a business overall and an industry manage the change and manage the differences. And particularly in today's climate, it's justifying and managing the associated costs, and there is a cost difference. So yeah, so a little bit about NR60 Mk2 and Mk2 development. I apologise if people know some of this already, but I'm always conscious there are people who probably don't know some of the history. So I thought I'd just start from very basic principles, but I will move over this quite quickly. So SEN60 S&C, what is it? So it's all to do with the rail section. It's a SEN60 rail section, which is taller and therefore stiffer than the 56 rail that we use. And with SEN60 S&C, generally the bearers are closer together, so it's a 650 spacing rather than we've used 710 for vertical S&C. And the running rails are inclined, where the 56V is V for vertical, of course, and the gauge is 1435, which gives us a much better wheel rail interaction, better vehicle dynamics. So this N60 S&C, it's not something we've dreamt up. This is used very widely, certainly in Europe, and even throughout many parts of the world, not exclusively, of course. So that's what it's all about. So why? What are the benefits? A stiffer track form. So the combination of this taller rail and the closer bearer spacing give us a stiffer track form. It's the same for SEN60 plain line as well. But in the S&C, this is really important because the loading on the ballast and the formation is reduced, and it gives us much better support for the switches, the crossings, and the POE, and they all work better if they're supported better. There are low bending stress in the rail, so you get less rail defects, and with the inclined rail and the 1435 gauge, there's like I said, better wheel rail interaction, so less RCF, yeah, better vehicle. I don't need to read the rest. It's better all round. So a little bit of potted history for those who weren't around at that time. So our first foray into SEN60 S&C was in the late 90s, so in the days of Railtrack. This was called RT60. There were 4 designs. Each one was developed by our manufacturers at the time, and we ended up with manufacturer-specific components, but there were lots of commonalities. So the Railtrack model specified the geometry of the layouts and the crossing footprint. the sort of main things that stand out are the geometry is different from vertical designs, and the switches use a higher cant efficiency limit. So two quite differences. The picture on the right there is the Balfour Beatty RT60 that I was involved in building those layouts some 20 years ago now. So that was my first experience of RT60, and then in 2005, 2006, Network Rail decided that you know, that this needed to be rationalised into one design, which I think was always the original. It was the intention anyway. So they bought the rights to the Edgar Allan RT60 design. A few minor changes. The PoE was then standardised to high drive. So the picture on the right there shows high drive, and that became the new norm. And there were lots of layouts installed. And but as time went on, so we sometimes refer to this now as NR60 Mk2 because we've got a Mark II. So there were challenges about cost. Some things don't change. The footprint, because it was different from vertical S&C. So where a lot of these units were installed on the West Coast main line, this was part of the route modernisation programme that was going on. It wasn't an issue because junctions were being remodelled, speeds were being increased. But as the layouts were being rolled out into like-for-like renewals, then that was a bit of a challenge. So now again, there's different views on that, whether you could fit things in, change things around, go up or down a switch size. But there were certainly issues. You couldn't do a like-for-like replacement. There were reports of crossing issues. Again, some things never change. Exactly why they occurred, that there seemed to be a glut of obtuse crossing failures on SEN 60 at the time. Certainly the problems haven't gone away that people expected to go away. And one of the bigger problems, and talking to people, particularly sites like Reading, switch wear and switch damage. So where we have short switches in NR60 Mk2 and we have trailing moves from heavy freight vehicles, then we get breakout on the switch blades. And so there are a number of sites around the UK where this was a problem and remains a problem really. It's been managed in certain ways, but that was one of the big challenges. So I'm going to just talk a bit about the development. Again, this is all it's all history, but just to remind people. So the whole point around Mark II was that the geometry was compatible with NR56V, and I have to say compatible rather than identical, because if you change the gauge, then the geometry changes. So it does have to change a little bit. The switch geometries for the shorter switches, so, and there's a diagram to just explain this in a moment, that's almost identical to 56V. The SWI switch, we've made a slight modification to reduce the entry angle, but essentially they're all the same. The longer switches use a slightly different switch geometry principle, tangential geometry. So the old HV and HVS switches follow this principle, and again, it's a common practice in Europe. We avoided using the clothoid, so this is what was used on the previous NR60 switches, and this was certainly one of the contributors to the switch damage problem I've just talked about. And because it helped, because we were managing the we were matching the footprint of vertical S&C, we could lower the cant efficiency figures as well. But some of the learning as we've gone along said actually running switches at high cant efficiency again doesn't help the wear, doesn't help ride comfort, as well as we've learned in time, and I'll mention a little bit about that later. So yeah, so the whole thing is matching the geometry we've got with vertical, but it is managing this switch entry so that we eliminate the problems that we now know about. So two diagrams there, and I'm not going to go into a lot of detail, but essentially say the top one shows it's actually a different radius through the planing radius differs from the turnout radius. So that's, like I say, that's matching the vertical switches that we've used for a number of years. You do get a bit of an abrupt change, but at lower speeds that's acceptable. But you do get a switch that's thicker, and you do get a switch that's certainly better to resist these high forces, and it's better in the trailing direction. So where you get the high lateral forces in the trailing direction, we've gone for a switch that's more meaty, but it doesn't give you such a smooth transition. The tangential geometry continues the turnout radius towards the mathematical point. Something a bit special happens near the toe, but essentially that gives you a smoother switch entry. So as the turnout speeds increase, then you get a smoother entry. Obviously, this affects the footprint as well. So when you look at a diagram, then the C and D switches are almost identical to vertical S and C. The E is slightly different. Can't quite explain why at the moment, but the longer switches, you do actually start to gain a little bit of length. So the nose to toe dimensions do expand a little bit. So if you were looking to do a like for like replacement where you'd got a ladder or a lot of turnouts altogether, so I know Southall was a particular challenge where we're trying to work around existing 56 layouts. It can be a challenge, but largely then you can replace 56V with or early vertical layouts with NR60 Mk2. So one of my colleagues, Andrew Turner, did this graph a few years ago, and I thought it was worth mentioning. So it's all around. I've talked about switch entry. So the design handbook for years talked about the instantaneous change of cant deficiency at the switch toe, at the switch entry, and it pretty much said it's high for S&C, so we just ignore it. And learning in the last few years, and particularly with the report of a ride comfort issue at a place called Searchlight Lane on the West Coast Main Line, then made us look into this in more detail. And the two dotted lines there are from the EN that's quoted on the right there, and the yellow line is the recommended limit, and the blue is the exceptional limit. So so we try as much as possible to keep our S&C below the yellow dotted line, and if you go above the blue line, then it's above the limit that's specified in the EN. So after 20 years, we discovered that the H switch had this was the NR60 Mk1 H switch, had a ride comfort issue that had never been picked up before, never materialized before, but we were getting this very high rate of change. So so by moving back to the principles of vertical S&C, we've pushed things a little bit further, but essentially we are managing that switch entry quite differently. And I'll talk a little bit later about longer switches, but this principle is being followed so that we keep the values to a reasonable minimum there. So switch flexure. So this is something that sort of dates back to BR research days, but a lot of learning has increased. So over the last few years, we've learned a lot more about switch flexure. So when we developed NR60 Mk2, I think it's the first time switch flexure was used and the switches were developed from first principles. So this is thinking about when you open a switch, what loads and displacements come into play. Where does the switch want to bend? So it's all then about where you connect the points operating equipment, the POE, and what the throws and displacements need to be, and like I say, how much load is needed. Points operating equipment we use for Mk2. Initially, it's been an evolution of existing technology, but the key word there is evolution, because the in-bearer clamp block was taken to a Mk3 model, and this was something that was proposed by the manufacturer to eliminate known failures. So it was a change to eliminate known failures. And the tubular supplementary drive, not to be confused with the tubular stretcher bar. So again, this was an evolution of the supplementary drive design that's been around for years. So works on the same principles, but it's just been redesigned from scratch. And for those who are familiar with London Underground, they adopted a similar system a few years ago. French S&C systems like the ones you get on on high speed 1, they use tubes instead of the channel rodding. And I'll talk a little bit more about that later. So we did the theoretical study with the flexure. Whenever we then wanted to develop a switch, we do some testing to establish that the analysis is correct, and to establish something I call headroom. And this headroom is really important with NR60 Mk2, because what we said is, if I mean, in this case it's the clamp lock. The clamp lock is a hydraulic unit. It operates from a power pack that has an output, a maximum output and maximum pressure. If you get to a point where that unit reaches that pressure, then it will stop working. So really the question is, what's the normal demand on the system? How close to that maximum level do you want to go? And this headroom is really the difference between where the switch will comfortably operate and the maximum output of the machine. And we're running at the figures obviously vary, but we're running something like 60% maximum. So we've got about 40% capacity spare in the machine. Some might call that an inefficiency, but you know, for a number of years I've been very critical of systems that operate very much on the edge. If you get it set up right, if you've got the right lubrication, if the weather's right, it will work. If any of those things are not quite right, it'll fail. Obviously, you know, that's not acceptable on today's railway. So we've really gone to town with this headroom, and that's been one of our guiding principles all the way through this. So we're talking about a couple of systems. I thought I'd just include some pictures there. So the one on the left is the mechanical supplementary drive, as the posh name is, or back drive, as most people call it. And the bit connecting the front and the back is a tube, so it's like a scaffold pole basically. And I'll talk about some benefits of that later. So that's developed for B, C, D, and E switches. If you go to the one on the right, that's the high drive. So the bit at the front, the primary drive, is the same. It's the in-bearer clamp lock, and so in this case it's the Mark III unit. But the rear drives are driven hydraulically, so it's powered from the same power pack as the clamp lock. And for anything above an E switch, we concluded from our testing that you cannot get the right level of headroom with a mechanical supplementary drive. So we went so for anything bigger than an E, we've mandated a high drive. So that's they're the systems available. So the focus is on the longer switches for the high drive, but you can use it on smaller switches. So an E switch, for example, on a high cant, you may choose to go for a high drive as well, because obviously when you're driving uphill, you need more force in one direction. So we did a lot of work on cast crossings. You'll be pleased to know I'm not going to talk about all that again, because I did that at the PWI for this presentation last year. But the analysis we've looked at, NR60 crossings, they have a longer life on average, although not always, and there's lots of factors that can affect the life of the crossing. But there's definitely a lower risk of fatigue cracking from the base. There's actually more cracks occur on the top, on the running surface. So yeah, just summarising what I've said before, really, the Mark II crossings are better in many ways. And how do we know this? Well, you can hear it. Any track engineer will listen to a piece of track, listen to a piece of S&C. They are surprisingly quiet for crossings. So yeah, I'm not going to talk about that. So the layouts, number of things changed with the layouts. I think one of the most the controversial was the introduction of the Skl Fastening System. So there are a range of clips, there are 4 different clips we use, which are all color coded. And there's a document at the bottom there that's our guidance note that tells you quite a lot of information about NR60 Mk2, but it tells you about all the different fastening systems. So the rail seats you see in the foreground there are, on the photograph, are it's a polymer wedge that's used to angle the rail. So this eliminates the need for cast face plates, and you still can get the inclined profile. And the exploded diagram on the right there is from Voslo, and it actually shows how the system works. If you look down that picture, you've got an insulated rail joint there, and the clips are a slightly different colour, so they're designed to fit around the joint more easily. And as you look further down, you can see we get into the base plates as we get towards the crossing and start with a check rail, and the clips are different colour again. So it's basically different coloured clips for different locations, but there are standard ones that we use. So a few other things to talk about. So the bearer joints, modular joints, again, bane of some people's lives, I know. The design is essentially the same, but the screws and the dowels associated with them are it's a Voslo system. It's a more modern design. So on Mark II we use the same fixings on all of the base plate fixings on the one I just showed you there, the screws for the inclined rail supports, the base plates and the bearer joints all have the same screws. The pictured top right there is it's almost like, yeah, what's this? So that's our new switch toe position indicator, which is essentially a hole in the stop rail. So you can see the rail there has a little hole, and we align the tip of the switch blade in the middle of that hole, and this eliminates the ball and claw. So again, on French railways, on high speed 1, this is what's used. The ball and claw has a lot of history, and one of the things it was intended to be originally was a position indicator, and that's all we wanted to use it for. So so we've moved it from the heel to the toe, because the POE setup is more critical at the toe, and we've got rid of the big heavy castings at the back, which as we know in the past have been prone to failure. So just to sort of make the point here, there aren't any stress transfer blocks at the heel. This is a switch that's allowed to, I call it allowing it to breathe. So with thermal forces, it's actually better if we don't restrain the switch at the heel, but it does need to be set up properly when it's installed. It's not installation proof, but in service it will definitely perform better. Picture at the bottom there, why am I showing you the POE again? Well, it's making the point here that the crank that's positioned in the forefoot there, the crank base is attached directly to the concrete bearer. Now, having said it's directly into the concrete bearer, we've fitted a shear plate. So the shear plates, you may have seen them when you take the bearer shrouds off on the bearer joint. It's the same idea, but it's in the middle there. So that's just to give us a robust anchor into the concrete. But we've put the POE cranks directly onto the bearers, and it keeps a consistent construction height all the way through. So that was a bit about development. Pilot sites. That was the first train over Thirsk, which was the first layout to go in several years ago. So yeah, Thirsk, basically it's on the East Coast Main Line. It's 100 mph on the through speed. One of the crossovers is only used in emergencies. The other one is a facing crossover as trains come out of the station on the slows onto the fast lines. So this has performed really well. The TME and the local team are really happy with it. No performance issues, minimal maintenance. Thirsk South, called Thirsk Green Lane, was installed at the same time, and within a few months, and this is actually on the same line. There have been a number of issues with that, with the crossings, with POE. Having said that, you have to sort of confess there were some early POE problems, but these were teething troubles. One of them was a manufacturing issue, one was an installation issue, but it's performed really well. And that when I'm asked about NR60 Mk2, I always go back to Thirsk, not physically, but just say it's been in for 4 years now, 4.5 years. So and it's doing really well. The crossings are very quiet, and if you look on a trace, that very small dip angles for the crossings. So it's a bit of frustration at the time. I remember we installed Thirsk, and then we installed no more until 2019, and we called those pilot sites as well. So Ulsaby, which is in the north that's heading out to Immingham Dock, so it carries an awful lot of freight. So it's a lower line speed, and we incorporated some premium rail steels into that, which I'll talk about in a bit. And we did Farnborough, so that was the first crossover, or 2 crossovers we did with Third Rail, and then we did Cogload the same year as well. So so the early sites we were dealing with the project team in Doncaster, and then it was the team at Bristol who did the Farnborough and Cogload layouts. And then what's happened since then? It's we did Cricklewood in 2020. So that was it was the first G switch we did. It was a G28 transition crossover. It has a 2-level design as per the one of the older designs, and it was also the first time we used high drive. So it was actually quite a long way down the line. And then in 2021 we've done some special layouts. We did a double junction and a 3-line crossover, and there are many other sites now installed. So it's over 30.10s. I was going to check the exact number and didn't get that far. So let's start the evaluation then. So is it the right solution? So all of the layouts installed to date, yeah, they're all performing well. Just said about the timescales there. So so Thirsk and Alsaby are ones we've been monitoring really closely. We've been back to them many times, and we've taken measurements and things like that. So the others, you know, we're still interested in, we're still keeping an eye on. But they're the 2 that we've been back to. And partly the reason we're focused on these is because one's on a high speed line and the other one's on a high tonnage line. So, you know, we're getting very different service there. In terms of geometry, I mean, generally when you look at NR60 layouts, I've talked about the stiffness being higher already, then the geometry generally remains good. But this actually came in this morning, this trace. Now, I don't know if you can see where I'm pointing. The red line indicates the switch toe, and the crossing is to the right of that. So there's a very small dip angle for the crossing as well. But it's quite uncharacteristic. And Thirsk, I've not seen a recent trace for Thirsk, but certainly seen some of the other ones that the S&C is almost invisible, because normally you can spot the S&C a mile off on a trace. So you know, we've got some geometry that's good, and it does seem to be stable and maintained. And when we've been and done site visits, we always spray up the switch and crossing when we're able to go when the line's open, see trains running over it, and in all cases the wheel transfer is very good. So yeah, so that's definitely a success. So talked already about quite a bit of this actually. So I've said that the Mark III clamp lock was you know, intention was designing out failures. The tubular supplementary drive. So if anyone's looking at the design of an old system with the channel rod flexes an awful lot, and when you analyze it, there's an awful lot of losses in the system. So the tubular sup drive, along with a number of other changes, there are quite a lot of other changes through the mechanical system, then it's a lot more positive drive system. And because of this as well, the system operates the same way in tension and compression. So channel rod behaved quite differently, whether it was pushing or pulling, because obviously you get the flex when the channel rod's in compression. But with this being a rigid tube, then it operates the same in each direction. And if you've got, like I said before, if you've got a cant or a particular feature that meant it was harder to drive one way, if the supplementary drive was actually biased the other way, then this could make quite a difference. So we've had a few sites where we've got Mark II layout, and we've got a similar NR56 layout or something else nearby, and the Mark II layouts are performing a lot more reliably. Talked again there about, I think I've said all that already about the integration testing. The key thing is at the bottom there that the Mark II switches are designed to operate in this non-ideal conditions. And I mean, I know from my history that some of the switches some time ago, it was a challenge to get things to pass. You know, and I've seen lots of times when people have been working at things really hard to get them to pass because it's going to be checked the next day. And you know, I was really adamant with this that we needed to. It was more about understanding how to make it fail than how to make it work, because you can't be sitting on a knife edge with switch operation. So again, one of the $1 million questions, and I've been asked by people who are here today, is does Mark II have the same issues that we've got with Mark I switches? So we did some analysis on this several years ago, and there is it's much smaller, but there is still a high peak load on the steering switch, and you get that with any switch, unfortunately. But further analysis of this, and actually I was in a meeting last week with University of Huddersfield, who've been doing further modelling on this, and I need to look more deeply into the data that they've got. They didn't present everything last week. They were looking at the lateral load against the thickness of the switch, and that is the key here. When you look at a Mark I switch, the tip of the blade is very slender, it's very thin, and the high peak force definitely occurred on that thin section. Now with the Mark II, then the peak force occurs when the switch is much thicker, and the switch doesn't go to the same thin degree either. So so it's definitely much better than Mark I. I've always been struggling to say, hand on heart, this will never have a problem, because I don't think you can ever say that for any switch. So Ulsaby is, you know, I've said it's not a typical trailing wear site. It was a vertical layout. It wasn't NR60 Mark I or RT60, but it's, like I say, it's on the line to Immingham. It gets freight trains every few minutes, a lot of the day. It has suffered in the past. Now, partly for this reason, we've combined NR60 Mark II with premium rail steels and lubrication. But pictures on the right there show the condition of the switch. So this went in 2.5 years ago, and that is the condition, sorry, just short of 2 years ago, 2019, and that is the condition of the switch a couple of months ago. And the mini prof scans are again a few months ago. So John Hempshire went up there recently. So that is what the switch looks like after nearly 2 years of service. So that shows you what the site looks like. So there's a crossover, and then there are two switches. So there's a passenger train that goes between the two branches, and the freight trains go through on the middle. So what rail, what have we used here? The switchblade is called R350 HT. So it has a lot of similarities with the old, people remember MHT rail about 20 years ago, but it's a more sophisticated hardening process that's used. But like I say, it's a standard 260 rail that's heat treated. Because of availability of rail, the switch extension, that's the bit that's welded onto the back of the switch before we go into the rest of the rail. The stock rail, in fact, the rest of the layout is HP rail. So we've actually combined two premium rails. But after 2 years, the switches look unworn. The local maintainer and the local asset management team are, you know, I will say they're waxing lyrical. They're really impressed with it. So they've had no actionable defects. We've looked at the history in the 2 to 3 years before, and they just had loads and loads and loads of defects here. So the benefits of R350 HT, let's call it, it is weld repairable, and it is weld repairable as a switch. So so there's now there's a welding process for that. There's a competency, and that is available. So we've got a handful of our 350 HT switches in trial, but that's now being expanded, and to do that we've had to procure some more rail. So we've got the business case. I think that's now been agreed to get some more rail, but that's really really looking positive. Another switch has gone in at or near Waterloo as well. That only went in May. There were some delays in getting that in, so so we are obviously going to be monitoring that really closely as well. So bearer and modular joints, again, the bane of people's lives, I know. So it's the same design. I think we had to change just a few dimensions because of the bearer strand pattern, but like I say, it's a different screw and it's got different inserts. I'm not saying that's the only reason, but already said about the NR60 stiffer track form. We've also issued in the last couple of years the standard listed there, so design of the layouts and installation in line with that, but we've had no reported issues on an NR60 layout yet with broken screws or anything else. So Thirst and Sibley both have got bearer joints, and we have been monitoring them. So those little indicators that you see, the yellow indicators there, we've got a number of sites, and it's something Eastern Region are doing quite a bit to monitor if the screws are starting to work loose, because that's a telltale sign of the problems down the line. But again, we've had no issues with that so far whatsoever. So so that's all looking really positive. Similarly with the crossings then, again, I talked a lot about this before, but that's the Alsaby, one of the Alsaby crossings there, so you can see the wheel transfer, and all of the crossings I think to date have been EDH'd as well, so they're all pre-hardened. But yeah, they're all performing well. Like I say, very, very quiet, very low dip angle. You saw the one back there. So it's all good news, isn't it? Well, no, it's not. I mean, let's be straight. There have been some challenges, and there do remain some challenges, but I do believe these can all be overcome. So, so one of the biggest challenges is around familiarity. Everyone who installs S&C, who designs S&C, who maintains it, they're very familiar with what they've got. So what's been a key part of certainly the early pilot sites, so we worked very hard with Steve Varley at Doncaster for the first one, with Adrian Everson for the two further south, and it was very much about planning and meeting people and briefings and training, getting the right tooling, and I think just modifying the approach, because it is just thinking differently. You just got to think things through differently. The change needs to be treated as a project, and there is now best practice that can be shared, and there is a document I've talked about already, the guidance note. Sorry, I put L2 there, it's GN 065. So all the challenges around are, and I don't think this one's yet been resolved, BRT files, Bentley Rail Track files for the C switch. So I think I mentioned before, we put this extra radius in to improve the switch entry. Bentley can't cope with that. Maybe I should have made the switch worse, I sometimes think, to make it fit Bentley. Obviously not, no, that's just a joke. But the switch indicator, so it's a bit like ball and claw. You've just got to set the switch up before, when you stress it, when you install it, when you weld it. I think people have got used to switches with a fixed heel stress transfer block. The fastening system is very different, so it eliminates the temptation to put things in with hammers, but people need to know which clip goes where, and the correct torques and things like that. It's more of an engineered solution, and it's having the right tools to do that efficiently and quickly. Access for the welders. So again, a lot of the welders have not seen this before. Whoever's taking out the fastenings, this is something we certainly didn't fully consider on the first pilot. The welders come along and start taking things apart that they've never seen before, don't have the right tools for, so they need the right supervision. We recommend the use of alignment gauges for different reasons. So the welders either can't or won't use them. We have introduced now some plates, some alignment devices for the welders. So it's certainly areas. I mean, these are not reasons not to do it. These are reasons. These are things saying, you know, when you are doing NR60 Mk2, just make sure these things are all managed. The other one's material lead times. You know, this has still not become such a high volume system as 56, and we're still working, like I say, closely with supply chain on this. But particularly when projects are changing from 56 to 60 and back again, material lead times have caught people out, and when patterns don't exist for some of the components. But yeah, now that, you know, it can sound a bit negative, but I think these things are all they're all able to be overcome. But it is very much a case of if it's the first one that you've done, you know, you need to just think about the whole process and treat it as a project in its own right. Don't just assume everything will be the same as it would for a 56V layout. So the other challenges are costs, and this is a bit of a frustration because I go back to the original papers that were written back in 2009, 2010. The benchmark was the cost of NR60 Mk1 and the cost of changing, in some cases, overhead lines and things like that to fit that in, where you previously had a vertical layout. Of course, we reverted back to installing mostly vertical, so the benchmark has become NR56V, which is a cheaper system, and the NR60 will always cost more. So that is a bit of a challenge, but there's been some discussions recently. There's been some challenge from particularly from Eastern region, but I think it's a national challenge, which I perfectly understand. Is why does NR60 Mk2 cost so much more? Well, you need to break that cost down into different component parts. So it's the unit rate. What is the unit rate? Now, our target for that is 15% higher. It's probably between 15 and 25% at the minute for the materials. So this is when you're looking at a project, this isn't project cost, this is the materials cost. But if it's a first off, there are setup costs, there are patterns generally for plates, for crossings. So, but they will be generally a one-off. But as a supply chain is setting up, these things are there, and there are, I've called them initial contingency costs. Suppliers, contractors, everyone's unfamiliar with this. They've got to go through the learning and everything else. So everyone is building in a contingency. So yeah, the other point I've said at the bottom there is when comparing costs, make sure you compare like with like, because some people get an initial estimate for 56V, which is like the base cost. It's like when you go to buy a car. This is the list price. It's not the on the road price. It doesn't include the optional extras you want. So they're comparing the on the road price with all the extras for NR60 Mk2, and they're comparing the base price for 56V, and it's skewing the picture. So in terms of the cost, what will happen then? So the unit rate, it will go down as volumes increase, and there are discussions ongoing now with the manufacturers to actually agree the prices, because when we first started doing them, it was difficult to tie down and agree a list price. But enough layouts have now been produced by a number of manufacturers, so we can actually compare. So that those prices will go down. Setup costs, again, they will go down, and eventually will only be needed for non-standard stuff. But you know, that is something. And again, this initial contingency cost will go, but it needs to become the business as usual for everyone. So so yeah, so we've done the yes, that sounds all the negatives. So the benefits, so increased reliability, longer life of crossings, the switches and the whole layout, so reduced whole life costs. And I still believe, even with these higher initial costs that are being reported, that the extra cost, if you spread it across the whole life, is insignificant. But you know, there is a campaign from a number of areas to reduce the initial costs as well. So like I say, people whilst the challenge is there, you know, it is a justified challenge, and I've been pushing my colleagues in the supply chain team to say, come on, we need to really challenge these costs and push them down. So yeah, so that's really it. So just a quick bit on future developments, and I can take some questions. So a high-speed double junction for Uddingston, which is being installed at Christmas. So the picture there shows a switch diamond that's been developed, which is very much a first. So it's a first because we certainly have no history of a NR60 switch diamond, and we've not found anyone else in Europe yet that's got one. And it's got a new PoE system as well. So it's a VAE PoE system. So that's on test at Beeston at the moment. So team are working on that one. So double junctions, the picture a couple of slides ago was showed one of the double junctions that had already been done. So we've got a range of geometries now, so they'll be going to be developed when required, but resources are critical. So the people who need to do design, supply chain and approvals, they're critical. So things can be developed, but you need to just plan ahead and make sure the resources are available. And the other project is, now I've said higher speed rather than high speed, because high speed has a definition for those who are particular about those things. So there are some turnouts and crossovers under development. So we've based the switch sizes and the speeds on the vertical range. So the H switch is a 90 mph switch. So we've introduced for the first time an I switch, which will be 100 mph switch, turnout crossover, and a J switch 125. And these are being developed, but these are seen as an extension of the NR60 Mk2 range. There will be swing nose crossings in there as well, and the development of these has been funded by HS2 because the initial need is for connections onto the high-speed 2 line. So I just needed to say that it's very much been a team effort. I'm always conscious when I'm presenting this kind of stuff that makes it sound like what a lot of stuff I've done here. It's been a very much a team effort. So the S&C team have all been involved. Need to mention Matt Crompton. He's been the lead engineer over a lot of this development, but certainly other people, I've mentioned a few names already from the team, have been involved in the development, in the monitoring, in the PoE and everything else. Suppliers have been key. They've done a lot of the drawings for us. Universities and consultants have been involved, and the project teams, like I say, they're a real key part of this. So I just want to say thank you to everyone involved and just recognise that. So yeah, on the back of that, I can now take some questions. I've seen some popping in. So.
Well, thank you very much, Ian. Yes, let's open the floor to questions. So, Phil, I think you had a couple of questions already in the chat. Do you want to come and ask them?
Okay, thank you. I can turn my camera on if you want to see me. Right, it's toe positions. So that toe, hiya, Ian, good to see you again. The toe position indicator looks quite interesting. It looks, you're saying it's just a hole in the rail. So how do you actually set that up? I couldn't see any sort of markings, graduations on there. What kind of metric have you got, or is it that there's a bit more tolerance in there and therefore it's a bit more able to be flexible?
So it is very simple. So effectively, the plan is to line up the center of the hole with the tip of the switch. So simple check would be to use a rule just to measure half the radius of the hole, basically. We have talked and we keep talking about how accurate, whether we should have gauges and things like that. We've concluded as long as the switches are square, then it's not that critical, to the sake of a millimetre or two. I mean, again, as with a lot of these things, if the installation teams have other ideas, I'm happy to, we the team are happy to take any feedback on that. But I think the key thing so far, as long as people are aware of it, then it's not been a problem. It's more people are used to switches with stress transfer blocks, and if the switch has moved during transport, it's not been corrected.
Okay, so it's in the centre for any temperature, and then you just set it up with an anchor, and then stress the back of the switch rail.
At the moment, we're setting, and this is the thing about the accuracy as well. We've said we'll just set it up in the centre of the hole. We started off saying, really, should we start, if it's a hot day or a cold day, should we set it up in a different place? But obviously, you're going to get differences between summer and winter. But most of the setup's done at night. So yeah, it's more of a nominal position and just getting that consistent than being really accurate. We were very careful not to make something that was quite simple in something really complicated.
Sounds good. Giles, if I can carry on to my second question, I put 2 questions on the chat, if I'm allowed.
Yeah, carry on, Phil.
Okay. So noticed you changed the gauge back to 1435. Obviously, it's been traditionally 1438 on N60 stuff. So was there something driving that? It's not a big number. Was there an issue for that, or is it just for standardization for the TSIs and things?
I think it was for S&C 1435, and for our inclined S&C, then that's yeah, and the TSI, I think that was it. To be honest, if anything, it's some of it is a bit wide, so it does go up to 38 in some cases, and we're not getting stressed about that. But 35 is a good nominal. A lot of the like I say, a lot of the actual European equipment, the POE and everything is designed to operate at 1435, so it was more a standardization. But if it goes a bit wider to 38, that's fine.
Okay, right. I shall hand over to someone else. Thank you very much. Cheers.
Thanks, Phil.
John Barry, you've got a question?
Yeah, hi. Thanks for that, Ian. Just a quick one on 2049. Doesn't seem to be much information available for NR60 Mk2 layouts. I've been given various sort of bits and pieces, sort of second hand, if you like, but is that sort of confidence to, have something in the standards?
Yes.
Will that be issued at some stage with all information in?
So it will be. We wanted to do something sooner, and the idea was to do 2049 at the same time as 2102, but it became such a mammoth job. In the slide somewhere, it did refer to REPW 4299, which is where the geometry tables are. I don't think I mentioned that as I was passing by, but
does that include double junctions and sort of three line crossovers and things?
So they aren't published yet because they're not readily available, but Matt Crompton and the team have those. So I would suggest, because we did debate about publishing them, but the problem is once they're published, people will start assuming that they can just get them, and the REPWs have only been created for the ones that we're developing. So if you want to do any double junctions, then you need to engage with Matt and the team and agree, what sort of development work still needs to be done. But as far as the standard turnouts and crossovers 4299 is there.
Okay, thanks for that.
Okay, it's very much around just not having the money and resources to develop every option up front. So it's a case of starting with a small population and then developing the others as we go along.
But on one of our jobs in Streatham, we've been scoped to look at NR60 double junctions, NR60 Mk2 double junctions. But without the information to hand, it's with a chicken and egg thing. We can't really design it if we don't know.
No. Well, if I were to drop Matt a message and see if he can have a catch up, and then he'll share with you what he's got, talk about timescales, and then look at what's what's required. Yeah. Is that okay?
But so no future date for the Mod 03 being issued with all the information in. Yes, it's just whenever you can.
It's on the list, and to be honest, there's just a big challenge with lots of work at the moment from everybody.
Sure.
Yeah.
Okay, thanks, Ian. Cheers.
Sorry, I can't say anything any more positive.
Okay, thanks, John. Phil, you're on again.
me again. I was trying to leave some space for others, but back to me anyway. So another one for you, Ian. Switch diamonds sounds quite fascinating. Switch diamonds obviously have an interesting checkered history, and various RAMs around the country and TMEs and things will probably swear and curse at the simple mention of these things.
We've had all of that actually.
Yeah, indeed. So I'm just interested to know what the motivation for bringing them back is. Obviously, there was a move away from them for a whole variety of very good reasons. Is there a business need or a business case for them? And also, how sure are you that they're not going to get the same kind of issues coming back for the new system?
Right. So we so in terms of the coming back and everything else, so this one that's being developed is for a high-speed geometry with a flat geometry that you can't have a fixed diamond. And it's very much, again, it's a like-for-like junction. So I know many years ago that people were opening up double junctions to put ladders in and things like that. Space is obviously a constraint and cost. So this is a like-for-like replacement for Uddingston, and I sort of get the impression that's the very much the feeling at the moment. So it had to be a switch diamond. We've looked at the we've tried to get the people who say, you know, that like say all the swearing, get those people to sit in a room and say, well, what are the actual issues with the switch diamond? And we've really narrowed it down to stability, thermal stability, geometry stability, and POE that's tolerable, that's tolerant of the movement. So we've, I mean, part of the question is saying, well, really, you know, if you put it on concrete bearers, is the issue still there? But we've effectively focused on stiffening up the whole design. We've got strap rails down the outside. We've got more robust fixings on the wing rail at the knuckle, and say it's a POE system that's from Europe that it operates quite differently, so it's more tolerant of movement. So yeah, I think that's does that answer your question? Sorry, I know you asked several things.
I think that does. Yeah, that sounds really good. Sounds like you've genuinely tried to investigate it and genuinely tried to solve the issues and come up with something good. So I'm quite looking forward to that now.
Yes, indeed. So I think the other thing on fixed diamonds, you know, there was a move towards fixed diamonds where the geometry did allow some 10 years ago. I think there's a different view on that, because some of those, the high impact forces on those crossings cause quite regular crossing problems. So so with those locations, we've either got to really beef up the fixed crossings to make them better, or we've got to consider switch diamonds for the sharper angles. But we know that, you know, the issues I've talked about, the stability, the thermal movement, is more critical on the sharper angle. So we're starting with a sort of flatter angle here, and then we'll gradually move. But it is fundamentally different, and it's shallow depth as well, which is another one that causes people to shout. But yeah, it'd be good to see, actually. So it's on the ground at Beeston at the moment, and so it's due to go in at Christmas.
Awesome, thank you.
No problem.
Brilliant, thanks, Phil. Steve, you got a question?
Yeah, thanks, Jill. Hi, Ian.
Hi, Steve.
Have you you mentioned headroom, about the issue about in terms of reliability and the forces needed to move the switches compared to the effectiveness of the POE and system issues in between that. Can you expand a bit more on that? You mentioned, I think you said, did you say 40% or something that was a headroom or something that was still in it?
Something like that, yeah. But obviously it varies. So I think I'm right in saying with high drive, then the system is designed to cut out, I think it's 72 bar or something. So so effectively, if the system is running at 65 bar to make it operate normally, then you've only got 7 spare. So we were aiming for, and I can't remember the exact percentages, but let's say we said, well, if it will cut out at 72, let's try and get it to operate at 50. So we deliberately turned the pressure down to 50 and said, well, let's play around with it. And that's how you do it. You turn the pressure down. So the headroom, then that 40%. So that was that's where I got the figure from. It was something like that. So, and then some of them actually operated at 40 odd, you know, so we got it to operate 40 odd versus 72. And this is, like I say, this drives, it's not just an NR60 Mk2 thing, it's the use of high drive. A lot of our older systems, we know some of the 56V switches are very, very stiff and they're very hard to shut, you know, people talk about. We know some of the long switches with supplementary drives, and you know what it's like, you can fiddle around with it all day, you get it to work, and then you move something slightly and it doesn't work and things like that. So it's really that's really where the headroom comes from, that you can even set it up badly and it will still work. And that's what we found with the Mark II with the high drive stuff. We did a load of testing, you may remember, at Stoke at Grange Sidings, and we tried to set it up as badly as we could, and it would still work. You know, just set it to the wrong openings, put a twist fault in the track, you know, and do all sorts of things. It still shut. So it was, but that was really what me and a number of other people were saying, that it has to be that way. You know, it can't just be operating on a knife edge.
Yeah, good. Yeah, reliability really important. Thanks, Ian.
Okay, no problem.
Okay, so I can't see any more questions in the chat.
Okay, well that's can I just say, I mean, if anybody thinks of anything else, then you can sort of contact me separately at Network Rail, or say I'm actually on secondment with the supply chain team, so Matt Crompton is filling in my job, so either myself or Matt, but we're still working together, we're still talking to each other, so we're just approaching things from a slightly different direction, but yeah, more than happy to take questions separately if anyone comes up with anything. So
yeah. Okay, well, on behalf of everybody today, Ian, thank you very much for the briefing. It's great to have you back. As you said at the start, you know, you came last year, so having you coming to an update again this year was great. So thanks for your time, and I hope you enjoy your holiday on your narrowboat.
thank you.
Thank you. On this, just to remind everybody that our next sessions would be on the 8th of September. We'll be talking about triple split bearers, so another challenge here. I'm not sure if you've heard of it, but that was developed and installed for 9M Junction there, and we've got people from the Service Alliance coming on and speak to us about it. So on this, I hope that you all have a great summer, and I hope to see you all in September.